In this video, we discuss about K-means clustering algorithm. The K-means algorithm is a popular unsupervised machine learning algorithm used for clustering the data. Grouping the data points based on some similarity feature is called as the cluster. The K-means algorithm is used to partition the set of data points into K different clusters. The similarity is generally measured using a distance metric like Euclidean distance. It is the distance between 2 points in a 2D or 3D space. The Euclidean distance between the 2 points is given by the formula d equal to a square root of x2 minus x1 plus y2 minus y1 the whole square. The k stands for the number of clusters. The value of k can be determined using a technique like elbow or Silotti score. That is elbow method or Silotti score method. The elbow method, we compute the within cluster sum of squares value for different values of k, and then we plot the elbow graph or plot. The elbow point gives us an idea of the optimal number of clusters. The x-axis represents the number of clusters in the elbow graph. The y-axis represents the inertia, that is within cluster sum of squares value. After a certain point in the elbow, the y-axis decreases in a very slow manner. It means that adding more clusters will not improve the clustering. Each cluster has a centroid, which is the center of the cluster. The centroid means center of the cluster. We call it as the centroid. Centroid is the mean of all points in that cluster. Algorithm. First step is initialization. Select the initial cluster centroids in a random manner. For each data point, calculate its distance from all centroids. Here we use the Euclidean distance formula. The data point is then assigned to the nearest cluster. After assigning all points to the respective clusters, we recompute the new centroids. The new centroid is the mean of all points assigned to that cluster. Repeat the steps 2 and 3 until there is no significant change in the centroid value. That is, until it converges or a specified number of iterations are reached. Silotti score. It is an evaluation matrix used to measure the quality of clustering. The score ranges from -1 to +1. -1 indicates incorrect clustering and +1 indicates that well-formed clusters. The higher score means better defined clusters. Applications are customer segmentation, image compression, anomaly detection. For image compression, it reduces the number of colors in an image by grouping similar colors, and it can be used for identifying the outliers. We can find the data points that does not fit well with any of the clusters. Advantages: it is simple, effective, and work well with large data set. If we see the disadvantage, selecting the optimal k value is a challenging task. The initial choice of centroids can affect the final result. The k-means assumes the clusters are spherical. It may not perform well with clusters of different shapes or densities. Now we will see the implementation of k-means algorithm. We see the implementation using the Google Colab. So here we import necessary libraries. Here we read the data set and display the data set, and then we standardize the data. So the standardization is an important step in algorithm like k-means. The standardization ensures that each feature has the same scale or same range. The dimensions will not be in the same range. To transform it to be the same range, we have to do the scaling or standardization. So here we standardize the data. Here this is the method. Standard scalar is a method. This creates an instance This method creates an instance of the standard scalar class and stores it in the variable scalar. And then we see in the scalar that fit transform. It is a method that fits the scalar to the data. Then it transforms the data. So here the next step is generating the elbow graph, calculating the optimal number of clusters using the elbow method. So here the WCSS, we can see list of here in this line, the list is to store WCSS values. We use the list to store the WCSS values. We use the for loop. This for loop iterates over range of values for k. For each k, the k-means algorithm will be applied to the data to calculate the WCSS. And here this is the algorithm name, that is a method k-means. First argument n clusters equal to k, that is the number of clusters, and then we see init equal to k-means plus plus. Initialization method for selecting the initial centroids. The k-means plus plus is an algorithm that spreads out the initial centroids more efficiently. Here the next one is maximum underscore iteration equal to 300. It shows the maximum number of iterations. Then n underscore init, it specifies the number of different initialization of centroids to run k-means. Then we can see the random state is given as 42. So each time we run this code, it will generate the same output. So the process of initialization centroids in shuffling the data will be always the same. Next, if we are not initialized, if the random state values are not given, then we will get different results each time when we run the same code. Then we can see the k-means dot fit x underscore scaled. The fit method is to fit the model to the standardized data. The fit method is to fit the model to the standardized data. Next, we append the values. The inertia values is appended to the WCSS list. Next, we plot the elbow graph. So we run this, and then so after running this code or executing this code, then we generate the elbow graph. Here we can see the plt.plot, that is the method to generate the line plot. The first argument represent the x-axis value. The WCSS, that is the second argument, represent the y-axis value, and the third argument is for customization. It specifies the marker or line style, etc. So the remaining lines or methods are to display the title, label, etc. So we will run this code. We get this elbow plot. So in this elbow plot, we can see the elbow here. So from this graph, we understand that the optimal number of k equal to 3. So we can see an elbow, that is a bend in this particular point, that is 3. So after this elbow point, the y-axis value decreases in a very slow manner. So from this we come to a conclusion that the optimal value of k is 3. So the next step is the generating the k-means. So as I said earlier, optimal k value equal to 3, and these two methods we have already discussed in the previous section to generate the clusters. So next we come to this next part, that is visualizing the clusters. So here we visualize the clusters. So I will just execute this code, and then next step to visualize the k-means. So here we can see two methods, plt.scatter, again plt.scatter. scatter. That is two methods. The first method is to display the scatter plot. That is the data points. That is the clusters. Is to visualize the clusters. K means clusters. And the first argument is the first dimension. Second argument is the second dimension. And then we can see y equal to c equal to y underscore means. It indicates that which cluster each data point is assigned to. It indicates which cluster each data point is assigned to, and we can see the size s equal to 80. So that is the size of the data points. So here, for example, I will just change it as 40 and I execute the code. Now we can see the data points up visualized in a very small size. So again I will just change it as 90 now. Now you can see the size is little bit big. Better to change it as 80. So it is visualization will be better. And then we can see C map equal to ascent. That is to display the clusters, each cluster in different colors. So there are a lot of libraries are available. From that we can use the values. And the plt.scatter. Again the second method. It is to display the cluster centroids. Here I execute this code now. So we are able to see the k-means clusters. There are three clusters and the cluster centroids are displayed in a red color. So two methods are scatter methods. The plt.scatter method is used to display the clusters and cluster centroids. And then we use here we can see the Siloty score. Here we generate the Siloty score. And again there are two arguments here. X underscore scaled is the data input data. Y underscore k means indicate which cluster each data point is assigned to. Here we print the Siloty score value. In this our coding we are able to get, or in this our algorithm we are able to get the Siloty score as 0.477. Hope you understand this demo. If you like this video, please subscribe, give your comments. Thank you.